Hi, I'm Catherine, and today we're going to do some implicit differentiation. By now you should all be very familiar with the chain rule, so let's review that process a little bit. If we have a function g of x equal to x squared plus 1 cubed, and we're trying to find the derivative, we know that to do the chain rule, you take the exponent, multiply down in the front, leave the inside alone, and subtract 1 from the exponent. And then it's very important to multiply by the derivative of the inside function. So the derivative of x squared plus 1 is 2x. Okay, so x squared plus 1 is just a function. So we can call that function f of x. So now when we look at g of x is just equal to f of x cubed. And then when we find the derivative of g of x, we do the chain rule. Bring the exponent down to the front and multiply by the inside, subtract 1 from the exponent, and then multiply by the derivative of the inside, or f prime of x. So that was a little bit of chain rule review. But when we're doing implicit differentiation, we're just using the letter y to represent a function of x. So the important thing to remember with implicit differentiation is that y is a function, not a variable. So if we were trying to find the derivative of y cubed, that would just be 3 times the function left alone, subtract 1 from the exponent, times the derivative of the inside function, or y prime, which we use to denote the derivative of y. Okay, so now that we've done a little bit of chain rule review and talked about how that relates to implicit differentiation, let's do a few examples, and hopefully that will make this whole process very, very clear. So when we're doing implicit differentiation, our instructions often say find y prime, or find the derivative of y. So for x squared plus y squared equal to 1, we just go through and take the derivative of each term. So the derivative of x squared is exactly the same as it's always been. It's just 2x. But when we get to y squared, we remember y is a function, not a variable. So we do something very similar to the chain rule. We bring the variable down and multiply by the inside, subtract 1 from the exponent, and then multiply by the derivative of the inside, or y prime. And then the derivative of 1, which is a constant, is just 0. But we're not done. We need to find y prime. That's what the instructions said. So we just use algebra to figure out what y prime is. So I'm going to subtract 2x from both sides and get 2y times y prime equals minus 2x. And then I'm going to divide both sides by 2y. So y prime equals minus 2x over 2y. And of course we can simplify that to y prime equals minus x over y. And we're done. So that was a simpler example, but now let's try one that's a little bit more difficult. So again, our instructions are to find y prime, and this time our problem is y squared plus xy plus x equals 1. So again, we're going to go through term by term and take the derivative. So like before, the derivative of y squared is going to be 2y times y prime, because I took the exponent down to the front, multiplied, left the inside alone, and then multiplied by the derivative. Now when we get to finding the derivative of x times y, it's a little bit trickier because we have x times y, which is a function of x. So we have to use the product rule, everybody's favorite. So I'm going to take the first part, x, times the derivative of the second part, and the derivative of y is just y prime. Then I'm going to take the second part, which is y, times the derivative of the first part, and the derivative of x is just 1. And then, so that was the derivative of x times y, so now the derivative of x is just 1, as it's always been. And the derivative of 1, which is a constant, is 0. Alright, so this is kind of looking messy, right? Let's simplify it a little bit. So 2y prime plus x y prime plus y plus 1 equals 0. But our instructions say find y prime. So what I'm going to do is get every term that does not have a y prime in it on the opposite side of the equal sign, and that gives us so I'm subtracting y and subtracting 1 from both sides, so minus y minus 1. And now if I look at this side of the equation, there are y primes in both terms, so I'm going to factor that out as a common term. So y prime times 2y plus x equals minus y minus 1. And now to get y prime by itself, I'm just going to divide both sides by 2y plus x. So in the end, we find that y prime equals minus y minus 1 divided by 2y plus x. And we're done.